Okay, so today's focus is going to be compression testing. Before we talk about compression testing, we need to focus on what every engine needs in order to run. Fuel, spark, and compression. And that's something that we have focused on, whether it's a single cylinder engine or a multiple cylinder engine. Each cylinder in that engine needs to have fuel, spark, and compression. Well, fuel by itself is not enough. Remember, for fuel to burn, we need to mix that fuel with air. And that's where our compression comes into play. Our compression is the mechanical ability of the engine to bring in air from the outside to seal the combustion chamber and then to squeeze that air, whether it's mixed with fuel or whether the fuel is introduced later in some cases. But we need to be able to effectively get air into the engine and squeeze that air in the combustion chamber. So what is compression actually? Compression takes place when the piston rises in the cylinder. We talked about the four-stroke cycle. By now you should have some understanding of the four-stroke cycle. Intake, compression, power, and exhaust. Well, on that second stroke, after the piston has gone all the way to the bottom of the cylinder and the cylinder is as effectively filled with air as it possibly can be, that piston begins to move back up on what we call the compression stroke. And it's squeezing that mixture into the top of the combustion chamber. And that does two things. That raises the pressure of the air. Remember, the way we're getting power to our piston is by increasing the pressure of the air. Initially by compressing it, and then by combusting the mixture and allowing that hot mixture to force the piston down, which is where the second part of this comes in. It also raises the temperature of the air, and it gets that air much closer to the combustion point where it can be ignited by the spark plug. So it raises the pressure and it raises the temperature, which prepares that combustion chamber for the actual combustion of the fuel mixture. Some things that can cause low compression. Number one, the cylinder is unable to fill efficiently with air. What can cause that? A restriction in the air intake would be one thing that can cause that. Well, what could be an example of a simple restriction in the air intake? How about a clogged air filter? Something as simple as a plugged air filter can actually cause a low compression reading on an engine. Now, if we have a low compression reading across the board, all of our cylinders are reading equally low, that could be a really good indication that we have a clogged air filter. How do we determine that? Remove the air filter from the equation and see if we still have a low compression reading. If we do, then something else is wrong. The intake valve not opening properly due to valve train issues. Now, that could be that the intake valve is not being allowed to open as wide as it should, like, for example, a worn-out camshaft, or it could be that it's not opening at the right time. For example, a jumped timing belt. So this compression test can point us in the direction of a lot of different mechanical problems that can take place. So again, a valve timing related issue can also lead to this. The second part of this, if we're able to effectively fill the cylinder with air, is what happens if that air is escaping during the compression stroke. So a compression test is not really just testing our compression stroke, it's testing the effectiveness of our intake stroke and our compression stroke. If the cylinder is not sealing properly, air will escape and we will not have a good compression reading. That could be from an intake or an exhaust valve that's leaking. It could be from piston rings that are not sealing properly. In the intro class, we installed pistons and we talked about the importance of the rings. It could be that the cylinder head gasket is leaking. It could be that the cylinder head is cracked. And there are other parts to this. But in general, a low compression reading means one of two things. It means either we're not effectively filling that cylinder with air, or we're not effectively sealing that combustion chamber and keeping the air in there as the piston moves back up on the compression stroke. It's important to understand this concept of cylinder pressure. Cylinder pressure is what forces our piston down in the cylinder on the power stroke. And it takes a lot of pressure to do that. In general, the more pressure we can create at the right time, the more power we produce from our engine. When we look at this graph, there's two different graphs being shown to us here. The upper graph is when combustion takes place. The second one is when there is no combustion taking place. I want to point out the differences because this is very important, although I don't expect you to understand all of this right now. This is very important in understanding what's really going on during a compression test. The first thing I want to point out is notice the graphs are the same up to a certain point. They're the same up to the point where ignition takes place. Once ignition takes place, notice that the upper graph, which is where there is combustion taking place, increases in pressure very rapidly, very quickly to over 800 pounds per square inch, and it could even be higher than that depending on the engine. That 800 pounds per square inch is what's driving that piston down in the cylinder and producing the power that is powering our vehicle down the road. When no combustion takes place, notice our pressure does continue to increase as the piston moves up in the cylinder, but as soon as the piston starts to come down in the cylinder, the pressure starts to drop off equally. Well, it would make logical sense. If there's no combustion, then we're not going to have any increase in pressure. Well, why would we have a decrease in pressure? Well, think about it. What's happening is as that piston, which has been moving up and making this space in the top of the combustion chamber much smaller, starts to move down, that space becomes much bigger and the pressure begins to drop. We can actually use this concept for diagnosing complex engine-related problems. Like, for example, if we have an exhaust valve or an intake valve that we think is leaking, we can actually see that in this pressure graph. This pressure graph really should mimic, if there's no combustion, it should mimic the graph going up, and the graph going down should look perfectly symmetric to one another. If we have a leaking intake valve, some of that air during compression will escape, and our graph as the pressure drops will not look the same. I know that's a little ahead of where we are right now, but it's an important thing to understand. Notice that during normal combustion, so this is when we are igniting the fuel mixture, notice our pressure spikes up to about 16 or so degrees after top dead center as the piston starts to come down. That's where we want the maximum pressure to be achieved in our cylinder. There's other factors that affect that. For example, more compression will cause our fuel to burn faster, meaning that we will reach that maximum pressure earlier. Ignition timing affects that, where we actually light the mixture of air and fuel. So there's a lot of variables to this. The speed of the fuel burning. We talk about octane rating of gasoline. A higher octane gasoline burns slower, and therefore we will actually see that pressure increase, or that pressure maximum at an earlier time. And if it's too early or too quick, we get something called detonation, which can lead to problems with engine parts. So let's go ahead and jump into this compression test. So as with any other procedure, the first thing that we're going to do is make sure that we are wearing proper eye protection. The next step is to go ahead and remove our spark plugs from the engine. So we've done that already. I'm not going to show that in the video. If that's something that you need a review on, I have previous videos that you can look at for that. But what I've gone ahead and done is I've removed the spark plugs from this side of the engine, the easiest side of the engine to access. We're doing this in the interest of time. The correct way to do this test would be to remove all 6 spark plugs. Due to the time constraints that we have in this class, we're just going to remove the front 3 that are easiest to get to. On this particular engine, that happens to be cylinder 2, 4, and 6. On the Bonneville, that would happen to be cylinders 1, 3, and 5. We want to make sure that we are labeling our spark plug wires correctly as well. Again, if you need a reference on that, you can look at the video that was already posted on that. So now I'm going to go ahead and I'm going to take my compression gauge. This is my compression gauge. And what I'm going to do with my compression gauge is I'm going to install that into the cylinder that I want to check. I'm going to install this in place of my spark plug. So we'll go ahead and thread this into the cylinder. Once we get the threads to start, we'll go ahead and tighten up our compression gauge. It doesn't have to be real tight, and we'll lay that off to the side. Now the next thing we need to do is we need to make it so that our engine will not start. Well, how do we make it so our engine will not start? The easiest way is to make sure that we are removing fuel and spark from the engine. We don't really want to have the engine trying to produce spark with our spark plug wires not connected to anything. And also, we don't want fuel entering the cylinder. Well, the most effective way to do that on this vehicle, and there are different methods for this, is to remove the fuse for the vehicle's computer. On this particular vehicle, the engine will still crank with the fuse removed from the computer. On some vehicles, we can't do that, so we need to follow other methods, such as removing a fuel pump relay or a fuel pump fuse. So we're going to go ahead and look at the diagram of the fuses. So looking at my diagram of my fuses, I can see that fuse 33 is the fuse for the ECM, electronic control module. And if I take a look at where fuse 33 is in my fuse block, we're going to go ahead and remove this 10 amp fuse right here. So I've just made it so this vehicle will not start. And I'm going to go ahead and hook my vehicle up to my jumper pack so that the vehicle will crank over. Now what I want to do is I want to go ahead and crank this engine over for about 4 or 5 seconds. During that cranking time, that compression gauge will gradually climb, and I want to look for what that reading is. I want to make sure that I see at least 2 to 3 good compression strokes, and what those 2 to 3 good compression strokes will be represented as the jumps in that gauge. Now you're going to notice this vehicle will sound a little different doing this compression test than it normally would. Normally, with all the spark plugs removed, we would not hear any compression strokes taking place. And I'll point out what that difference sounds like. In addition to that, we want to make sure that our throttle is wide open when we do this test. So I'm going to go ahead and I'm going to depress the gas pedal all the way to the floor. And with the gas pedal depressed to the floor, we'll go ahead and crank over our engine. So we can see this engine has a compression reading of approximately 155 psi. We saw the compression reading jump as we were cranking the engine over. So what does this all mean? Is this a good compression reading? Is this not a good compression reading? Let's go ahead and break this down a little bit closer and analyze this. But before we do that, we're going to go ahead and remove the compression gauge and repeat this test for our other cylinders. Alright, so after I've completed these tests for my cylinders, notice that my results are cylinder number 2 was 150 pounds per square inch, cylinder 4 was 150 pounds per square inch, and cylinder 6 was 160 pounds per square inch. Now, how do I know whether these compression readings are good or not? What I need to do is I need to go ahead and I need to look up the specification on ALLDATA. So I'm going to go into my ALLDATA for this vehicle. I'm going to go to my login center, go under repair, and I've already looked up this vehicle, so I don't have to worry about searching it. And this is the 99 Pontiac Montana truck. And I'm going to go ahead and just do a search for compression. And sure enough, engine compression test. And this gives me a couple things actually. This gives me a procedure to go through for doing the compression test, as well as my important information that I need, which is right here. So what it tells me is that the lowest reading should not be less than 70% of the highest reading. So we'll talk about that in just a second. And that no cylinder reading should be less than 100 psi. So there's 2 comparisons we're going off of there. So the first thing is the minimum compression reading is 100 for all 3 cylinders. Well, I have 155, 150, and 160. I've well exceeded that 100-pound minimum. Now, another thing that I want to point out, these readings are probably slightly lower than they even should be. And the reason these readings are slightly lower than they should be is because, remember, I only removed 3 spark plugs from the engine. And in fact, when I was cranking the engine, what you should have heard is that the engine was actually speeding up and slowing down as it was cranking. The reason that's important is that speed up and slow down during the crank is because those 3 cylinders still have spark plugs installed, and they're actually reaching their compression strokes and trying to slow down the crank of the engine. That freewheel where the engine speeds up is on the cylinders where the spark plugs are out. Ideally, I would do this test with all of my spark plugs out, and the only cylinder that would be seeing any compression would be the cylinder with the compression gauge on it. If I did that, I would be seeing a slightly higher reading. The other thing that I can do as a comparison is I can try closing the throttle, and I can compare what my reading is there as well. There's some value to doing tests in that way also. So I want to know what my lowest reading as a comparison should be. Well, what I have to do is I have to take my 160-pound reading, and I want to go ahead and figure out what 70% of that is. So I'll go ahead and plug this into my calculator, and I'll say 160 times 0.70 equals 112. So my minimum reading based on the other cylinders should be 112 pounds. Minimum reading based on other cylinders, 112 pounds. Not 122, 112. So, are all of these cylinders within specification? Yes, they are well within specification. What does this tell us? If we were having a problem with this engine where we had a cylinder that was misfiring or a no-start condition, more than likely it is not due to a mechanical problem with the engine. More than likely that problem is due to a fuel or a spark-related issue. So this test is not the end-all be-all, but it does give us some direction that we can go off of. Now the final step in this process is that we would need to reinstall all of our spark plugs and our spark plug wires, and we would want to confirm that the engine starts. Again, if you need something to reference for that, I do have prior videos that you can look at on the removal and the installation of spark plugs as well as spark plug wires. Have a great day, everybody. Thank you for watching.